All right, so we are going to do 17.2 today, and we are going to be dealing with monomials. As a review, a monomial is single term, like a mono means one. And so when you look at something like, I'm just going to grab one here, this 2mqp to the negative 2, that looks like a whole lot, but it actually is considered a monomial. Okay, does anybody know why this is considered a monomial? Kind of a memory trick I gave you earlier in the year. How is the 2, the m, the q, and the p attached? Multiplication. A multiplication is like, you guys remember? They did in second hour. Multiplication is like marriage. Okay, when you get married, two become one. So even though this is a 2, an m, a q, a p, okay, they're very different, obviously, a bunch of different variables. They are considered a monomial because they're attached with multiplication. And anytime that anything is attached with multiplication, it's considered one. That being said, this whole thing is also a monomial because this is attached to this with multiplication. So it's still a big giant one monomial, which is why we can reduce it here in a second. We can reduce it to a single monomial. What stops it from being a monomial, and we'll get into later on in the next few indicators, and they're binomials or polynomials, is a plus or a minus sign. If this right here was separated from this with a plus or a minus sign, then this would be considered a monomial, and this would be a monomial, but the two together would not be because they're separated by a plus or minus sign. So anytime you stick a plus or minus in, it breaks it apart and makes it two separate entities. Kind of like when you get married and you have kids, right? The kids are in addition to your family, but they're not that one, that unit of one, right? Eventually they'll get married, they'll move on, they'll move out, and you're still left with you and your husband, or you and your wife, or whatever, you and your spouse. That's those two, you become one, supposed to be forever kind of thing. So the kids are an addition, they'll eventually break off and go on their own. They don't become part of the one. Okay. I know it's a silly kind of analogy, but usually the silly analogies are the ones that stick in your head when you have to remember, is this a monomial or a polynomial? Okay. All right. So I do want you, if you're at home, to pause the video and write down these steps on how to multiply a monomial, and then unpause, and we will get into the examples. All right, so example number 1, and based on our steps that we have, step 1 was to multiply the coefficients. Coefficients are the numbers attached to the variables, and even though it's not there, there is a coefficient with that v. It's just a 1. It doesn't change anything. 3 times 1 is 3. So when we're simplifying this, 3 times 1 is 3. That is step 1, which is dealing with multiplying the coefficients. Then in alphabetical order, one at a time, you deal with each variable. Now in the notes here, I've got multiply like bases in alphabetical order, because here in a minute, you'll see we'll have multiple variables, and you always want to keep them in alphabetical order. One, it's a very strategic way to do it to make sure you don't miss something. If you always do it in alphabetical order, then you know you're not going to forget an A or a C or some rogue D out there that not every term has it. It'll really help keep you structured, and it'll also put your answer in proper form, because when you're writing an answer that has numbers and variables, your variables really should always be in alphabetical order. Okay. The little star I've got there in that base, keep your base. I said that a ton when we did this last semester, when we were learning how to multiply like bases. So if you have like bases, it's base, you keep your base, and then you add those exponents. So if we come over here, we've done step 1, which is we've multiplied the coefficients. Next, we look at bases. Well, the only base we have here is v. And so it's base, keep your base. So we're going to keep our v, and it's 2 v's times 4 v's, which is a total of 6 v's. And if you forget that, here's why. V squared, if I break it out, is v times v. Everybody would agree with that, right? If I multiply that times v to the fourth means v times v times v times v. And now if I simplify that, I've got a long string of v's all multiplied by themselves. Anything multiplied by itself can be represented in exponential form. And how many do you have? 1, 2, 3, 4, 5, 6. And that's how we get that v to the 6. Now, this is the long expanded version of the y. That's not something that you need to do on each one of your problems, okay? It's just the y, v to the 2nd times v to the 4th, why you add those two numbers together, okay? All right, so example number 2, again, didn't really mean to when I was making notes here, but it just kind of happened. We have 1 times 3 again, okay? So 1 times 3 is 3. And now the only base we have is an x. So base, keep your base, and add those exponents. Well, 3 plus a -1 is 2. Okay, so even if it's a negative exponent, doesn't change what you do as far as base, keep your base, add the exponents. You're just going to have to be adding and subtracting negative and positive numbers. Okay. All right, and so far we haven't had to deal with step 3, which is deal with any negative exponents, because so far we have not had any negative exponents in our answer. So we're good to stop there, okay? And your instructions said should contain positive exponents only, so we're doing good. Everything has had a positive exponent so far. All right, this is just a quick example. I won't spend a whole lot of time on it other than to say when you add in extra variables, it doesn't change how you do it, except for the fact that you should really do them in alphabetical order. So 2 times 3 is 6. So that's dealing with my coefficient. And now in my problem, I've got x's and y's. And not every single term has an x and a y, but in the problem as a whole, you're going to have to deal with x's and y's, okay? Sometimes you might throw in a z, or it doesn't matter what variables are in there. Kind of pull back, take a big overview of the problem, assess all the variables you have to deal with, and then methodically, alphabetical order, just go through them one at a time. So x, y is what we have to deal with, so I'm going to deal with my x's first. I only have 1, so it just still is a 1, okay? I only had 1 x, I still only have 1 x. Then I look to my base of y, base, keep your base. And I've got 3 y's and 3 y's, which is a total of 6 y's. And that's your answer. Okay, so far so good. Not too terrible. All right, so let's get into when we start having some negatives crop up. All right, so step 1 is still multiply your coefficients. Now, you want to be careful. You have a 2 and a -4. Just use regular multiplication rules, okay? 2 times -4 is -8. So that does not get any more difficult than just remembering your typical multiplication rules, okay? Now, I want to look at all the variables I'm going to be dealing with. I've got M, Q, and P. So in alphabetical order, I'm going to deal with M first, okay? So I find all my M's, and I'm just going to color code this just a bit here. So I've got M and M. Whoops, that's not the M. Helps if I actually do the M. There you go. I've got M and M. Now, remember that that first M, it does have a exponent. It's not there, but it is there, and it's a what? It's a 1. You have to remember that that is an M, and it's 1M. It's an exponent of 1. So when you're adding up all the M's you have in your problem, right? Base, keep your base. How many total do you have? Well, you have 1 here, and you have 2 here, so you have a total of 3. Okay. Now we go to P. Okay, P is our next one. We only have 1 P in the entire problem. And it's right here. It's P to the -2. And for right now, I'm not going to worry about that negative. I'm just going to simply write it down in my building. I'm building my answer here. So I've done M. Now I'm going to do P. And it's P to the -2. Okay, there's the P. And then as far as Q's, I've got a couple of them. I've got 1 here that has an exponent of 1. And I've got 1 here that has an exponent of 1. So base, keep your base. So my Q's, I have 1 plus 1 is 2. Okay, that's the next step. Now, the final step is to deal with any negative exponents. And I highly recommend kind of what I talked about yesterday, which is give yourself a fraction line to build on. Whoops. Give yourself a fraction line. It's like when you're building a house and you give yourself the framework to build your house. If you don't frame out a house first, it's impossible to put up plumbing, drywall, electrical, all of that. It all attaches to that framework. This dash that's going to become the middle part of our fraction, Okay, this is our framework that we're going to build everything along. Now, this is super easy if you will do it one at a time. Okay, take every single term in this monomial one at a time and decide, keep it where it's at or move it. Okay, how about the -8? Keep it where it's at or move it. Because right now it's technically, we don't write it like this, but technically this is all over 1. So right now everything's in the top, right? So do we keep the -8 there or move it? Kind of a trick question, but it's not. Yep. Keep it. A lot of people see that negative out front and they think, oh, it's a negative, we got to deal with it to move it. Only if it's a negative exponent, right? So the -8 stays up top. So I leave it there. How about the m to the third? Keep it or move it? Keep it. So it's going to stay up top. How about p to the -2? Keep it or move it? Got to move it because we have to deal with that negative. Now, when we move it to the bottom, we drop the negative. Okay, now how about the q? Keep it or move it? Keep it. And that is the final answer. And that, I feel so bad for, but that's what second hour did not get. All right, everybody good with that? Okay, so let's move to an example like number 5. Now, a lot of times this throws people because there's no variables. Well, that's okay. If you remember your principle of base, keep your base, this is very, very simple to solve, because if you remember the base, keep your base, you have matching bases here, right? You have a base of 2 and a base of 2. That means your answer is going to have a base of 2. And when you have like bases, what do you do with your exponents? Add them. Because what that's saying is 2 times 2 times 2 times 2 times 2 times 2 times 2, right? It's 7 of them. So it's 2 to the 7th power. And because the instructions just say positive exponents, we're good to stop here. If the instructions said no exponents at all, you would put 2 to the 7th power in your calculator and you expand this out to a standard number. But since this lines up with our directions, we are good to stop right there. Okay? All right. Let's see. Now we're going to move on to a new concept or a different concept. So it's going to take a little bit of writing again. So now we've got another set of instructions, very similar, but different in themselves just a bit. I'm trying to watch pencils. How we doing? So you should have used the power to a power is a superpower should sound familiar to you. Okay. We said that a lot when we actually went through dealing with exponents earlier in the year. So a power to a power is a superpower. And that's just a silly way to remember that that's when you multiply. Because I would say the hardest part of this indicator is remembering when do you add those exponents and when do you multiply them. Okay. And so if you're doing a power to a power, that's when it blows up big. And that's when that multiplication comes in. Okay. That's that superpower. So the first thing that we always do is we distribute the power first. That's on the outside. And then we simplify any numbers. So like 3 to the second power, we would rewrite that as 9, because anytime you have numbers and variables together, you usually want to go ahead and expand out the number in standard form and don't leave it like 3 to the second power. Just write it as 9. Okay. So if we look at, I'm going to skip 6 for a second, only because that's kind of a special case. I'll come back to it. So for right now, I want to look at number 7 as the first one we talk about. Okay. So for number 7, the first thing we do is we distribute the power of 3, and it has to go to the 4 and it has to go to the n to the third. And we don't really see the 4 as having an exponent, but every whole number really has an exponent of 1. And so what you're doing when you distribute that is you are taking 4 is your base, and your base stays your base. And then you're taking 3 times 1, which is 3. So your new power is 3. Then you move to the next term, and that's an n, base, that stays the same, but you're multiplying the power of 3 times the n to the third. So 3 times 3, so your new number is 9. What was that? Sounded like a sick goat or duck or something. All right, so now our last step is to go ahead and simplify 4 to the third power. Technically, by the letter of the law, this is following the directions of no negative exponents. However, and I don't really know why, because if it was just 4 to the third, we would leave it. But since it's 4 to the third and then n to the ninth, anytime you combine the numbers and the letters, you really do want to go ahead and expand out your number part. So we would put 4 to the third power, which is 64, n to the ninth is your final acceptable answer. Good with that? No negatives to deal with, so we could skip step 3. All right, so let's look at this one. Step 1 is to distribute the power of -1, so the v and to the u. So when we take, and again, that v really does have an exponent. It's there, but it's not there. It's a 1. So the bases, notice your bases here always stay the same. The v is your base. It's going to stay a v. And then 1 times -1 is -1. Your u stays a u, and then 2 times -1 is -2. Now we've got some negatives to deal with, so I am going to give myself a fraction line to build around, and I'm going to go one at a time and decide, leave it or move it. So v to the -1, leave it or move it. Move it down to the bottom, because really, technically, we don't think of it this way, but all of that right now is sitting in the top of a fraction. So we're going to move the v to the -1 to the bottom. How about the u to the -2? Leave it or move it. Move it. So we put it down there. And then again, just the rules of math, you don't leave the top of a fraction empty, because really, okay, and we don't ever think of it this way, but why we really still have a 1 up there, okay? Why do we have a 1 up there? I mean, yes, we always say, well, we just don't leave the top of a fraction empty, so we stick a 1 in there. But really, that's not the math behind it. Is this was really a 1v, and this was really a 1u, right? And technically, what did we move? We didn't move the 1, because the 1 is fine. The 1 had a positive exponent. So we didn't move the 1. We just moved the v, leaving behind a 1. We just moved the u, and then we're left with 1 times 1, which is 1. It's a whole lot easier just to say, don't leave the top of a fraction empty. But the math behind it is that we really did leave behind 1s up there. Okay. All right. So let's jump back up to number 6. Remember I said anything at all, doesn't matter what it is, to the power of 0 equals what? That is included when it's a power to a power. And here's why. Okay. If you want to work it out, you can, but I'm going to show you why this is equaling 1 no matter what. If I take This is a 1 here, right? Everybody agree with me there? If I take my base of 3 and then I multiply 0 times 1, what do I get? I get 0, right? Then I take my base of x and I distribute my 0 times 4. What's my new exponent? 0. Okay, now I simplify this. 3 to the 0 power is a 1 times x to the 0 power is a 1, and 1 times 1 equals 1. So you can see that is a whole lot less work than this if you can remember that anything to the 0 power is 1, even if it is a giant monomial. Okay? All right, I've got 2 more examples. We are doing good. Yeah, you guys will still you guys will have about 10 minutes to work on your homework, which is good. Okay, so step by step, one at a time, we are going to distribute the -2 to the m, to the p, and to the q. So one at a time, my base of m, I'm going to mess with it first. And -3 times -2. Use your power of, your properties of multiplication here. A negative times a negative goes positive, so it is +6. Then go to your p. 2 times -2 is -4. Then go to your q. 2 times -2, I'm multiplying the powers here. Remember, a power times a power. So 2 times -2 is -4. Last, I'm going to give myself a fraction line, and I'm going to go one at a time and decide, keep it or move it. M to the 6, keep it or move it. Keep it. The p to the -4, move it. And when I move it, I have to remember to drop that negative. That's the whole purpose of moving it, is to get rid of the negative. How about my q to the -4? Move it, and it goes down, and that is my final answer. Okay. I'm gonna have you guys work this one, and then I'll work it, and we'll turn the screen back on. And if you guys are at home, pause the video for a second, try to work this on your own, and then unpause the video and test it to see if you were right. All right. So step 1 is to distribute that power of -4 into each term. So when I take -4 times, -4 times 1, right? Because this is a 1 there with that 3. -4 times 1 gives my 3 the new exponent of -4. My a also has an exponent of 1, even though it's not there. And if it helps to add it, I think it's very helpful to go ahead and add that 1 in there. It helps kind of keep you straight. A is your base. Don't lose any bases. You keep your A as a base. 1 times -4 is -4. For your base of C, keep your base, and then -4 times -4 is +16. Then start moving everything. Okay, so when I drew my line here, I decided that my 3 to the -4 needed to be moved to the bottom, because remember, everything is technically in the top right now. So my 3 to the -4 moved to the bottom. My a to the -4 moved to the bottom, and my c to the 16 stayed on top. And then the final step is to go ahead and simplify 3 to the -4, which is 81. And so your final answer would be your c to the 16 on top, and then 81, a to the 4 on bottom. Any questions? Okay, for those of you at home, shoot me an email if you have any questions. Otherwise, if you don't have the paper homework assignment, you can open the Kami version and do that, or wait till you return to school to get your paper copy.